Hello everyone and welcome back to the channel. Today what I want to talk about is 3D printed combat robotics. So first let's start off defining what is 3D printed combat robotics. Secondly, why it's cool and why I think you should be interested in it if you're interested in engineering. And then 3, my approach to a robot. This is definitely not the most optimal approach or the best approach, but I feel like I've made a few unique and interesting design choices that people might find useful for their better robots. So, what is 3D printed combat robotics? 3D printed combat robotics is making a battle bot out of fully 3D printed materials. It depends on the competition what type of materials that you're allowed to use. So PLA, ABS, PETG are all commonly allowed filaments. However, most competitions restrict TPU, carbon fiber reinforced filaments, anything that if you picked up an Ender 3 off of Facebook Marketplace for $100, you wouldn't be able to print. If you couldn't print it on that, then it's most likely going to be banned, because the point of the hobby is to allow for a more entry-level BattleBots experience. I know that most people have seen the BattleBots show, and if you've watched the show, you're like, these robots are really cool and they're really big. Surprise, they're like $100,000. I don't have $100,000. Most likely, not very many people have $100,000. So people were like, okay, since most individuals don't have $100,000, what can we do to make this sport more available to everybody instead of just a select few people? So, boom, 3D printed combat robotics was born. Why I think you should do it? It's a great test of engineering skill, a test of patience, and also a test of failure, because BattleBots break. That's kind of what they're supposed to do. They are supposed to be destroyed, so it hurts your pride every time one of your robots gets blown up, but also it's a very unique challenge. If you've ever done something like FRC, FTC, FLL even, the whole design philosophy, design style, it's very, very different. You're designing things to be robust, but also lightweight, but also simplistic, but also complex. So it's a balance of different types of design elements. So it's just a really unique challenge. It also pushes your knowledge and understanding of 3D printed materials and ways to create unique and innovative solutions that you might not have thought of in pursuit of reducing weight. I know that I'm going to highlight a few here today in this video. But it's also just a lot of fun. Like, if you have a 3D printer already, you can spend like $100 on electronics if you know the right ones to buy and get started. So it's not a very high cost entry point to be able to start in this hobby, which is why I find it really enjoyable, and I think it's a lot of fun for people. All right, let's dive right in. That's enough talking for today. Let's take a look at this robot. So typically, you're going to find 3D printed components in all levels of robotics. However, for specifically only 3D printed, it's going to be mostly restricted to a 1-pound weight class, and also fairy weight, which is 150 grams. Typically, people are going to do the 1-pound weight class. 150 grams is rather difficult to design for, at least when you're first starting off, and can lead to more challenges and less complex of a solution, at least in my opinion. So let's take a look at this. Let's break down a few different components and talk about them. The first thing is the weapon. There are, I'll say 2 main categories, actually 3 main categories of robots. You're going to have vertical spinners, which is what this type of robot is. You're going to have horizontal spinners, where if you were to think about this rotating, you would be able to see that it's going to spin this way, or vertically. This is a vertical axis of rotation. So what is a horizontal spinner? A horizontal spinner is something that rotates horizontally. I will put in a picture of what a horizontal spinner looks like. And then there's also things called control bots. These use lifters, flippers to be able to control the opponent instead of destroying it. Because when you're designing a robot, there are two main things that you can go for. You can either go for absolute destruction or control. Because when you're being judged inside of a match, there's two different ways to win. 1, KO, you knock them out. 2, control. So if you're able to pin the other robot the entire time during the fight and make it so they can't do anything, you get something called control points from the judges, and you can win matches that way as well. The only way to win isn't complete annihilation, unfortunately. So some robots do try to do that. So let's take a look here. So we just identified the weapon. In this case, it's called a drum spinner. There are different types of vertical spinners. Drum spinners are going to be the most common in 3D printed BattleBots, solely due to the length of them. If you had a really thin drum, which was not very thick, what you would end up doing is cracking it really easily, because even if it's 100% 3D printed, since it has such a small amount of surface area, at least in that whole, vertical plane, it would be able to snap easily and have large stress concentrations. So typically you're going to see longer drum type spinners. In this case, you're going to see something called cast resin wheels. So in this case, we use a mold and then we assemble, we pour the resin inside the mold. So here, this blue part is the mold. The black is the insert that we put inside the mold. And then you put in your resin, which forms as this gray part right here. You might see, well, what's this little section right here? Why is it not going out to the edge? That's a great thing. Let's take a look at that. So when we're making molds, there's an important thing that we have to consider. It's when you release the mold, you actually need to be able to get the part out. This is called a draft angle, and what it does is, instead of making the walls vertically straight, it turns them into more of a conical shape, or like a funnel. This is used in things like casting as well, in metal casting. It's also used in injection molding. You're required to have draft angles. The reason is because as soon as the part lifts out and stops making surface contact at this very bottom corner, the entire rest of the part is no longer touching the walls. So you only have to pull out a tiny bit for it to become completely free of the mold. Whereas, say if you had these perfectly straight or vertical, as you pulled the wheel out of the mold, it would actually completely destroy the exterior of the wheel, because it would be rubbing against that surface the entire time. The other thing that you can see is this little slot down here. This is for runoff. So as you fill this up with resin, some of it's gonna spill off a little bit. So it's better to have it spill into a little 3D printed channel than all of your desk, or start filling up and cure around some of your pulley teeth. That's removable. However, if we can prevent it, we're going to try to. Another case, you can see belt. So it's kind of hard to put a motor up here for these front wheels. So what ends up happening is there's a motor in the back that powers this rear wheel, and then a belt is used to come up to this front wheel, because having all 4 wheels as points of contact is much better than only having your back wheels. Because, for example, say your robot gets tipped up on one of its rear wheels, it still might make contact with one of the front wheels, so you'll be able to pull yourself off instead of being not able to move and being disqualified. So that's one thing to think about. In this case, I have a little bit of a wedge here because there is something called ground game. Basically, the closer you can get to the ground, the less likely it is for wedge bots, like that have really, really big wedges on them, to be able to get underneath of you and be able to tip you over. It also helps get opponents closer to the tooth or bite point of your weapon. Say, for example, your robot hits the top of another robot with its weapon. It's probably not going to launch it very high. But say, for example, your robot tips up another robot and hits them, it's going to create a much larger moment arm, which is a force over a distance. It's the same sort of idea as torque, and flip and be able to push the robot a lot farther away. So you're going to find wedges pretty common on a lot of vertical spinners. They might not look like a full wedge like this. They might use something called fork wedges, which are just forks sticking out from the front of the robot. Another thing is I have armor going all around the side of my robot. This is going to be pretty common trying to guard wheels. If you're a horizontal spinner, it's pretty easy to target people's wheels and knock them off. So being able to block from that and resist your wheels getting pulled off is typically a good idea. The interesting thing about the way my armor works is it only really has 2 bolts in it. It has this larger M5 bolt in the back and this shorter M3 bolt up in the front. The reason I'm not connecting my armor right here in the middle like you typically would, or how I've done in the past, I've actually had 3 bolts right here in the past, is due to this dovetail feature in the back. So if I do a section view right here, what you can see, let's make that go a little bit farther. What you can see is there's a dovetail feature built right into the main body of the armor and also the back armor piece as well. The reason for this is it confines all of the axes of rotation down to 1. The only possible way that this can move is if you pull it from side to side, then it would be able to move. Which is why there's a bolt up here that confines that movement, at least in the front. However, in the rear, it still has a little bit of slop to it, so we put this bolt in that joins both sides of the armor to make it so that they can press together so that we don't have that anymore. I also use that up here with my armor supports. My upright supports. So this piece right here that holds the weapon is called the upright. Typically you have a left and a right upright, and one of them houses a motor and the other houses a support shaft. However, some people use 2 motors. Some people don't have any motors up here and their motor is carried back here, and they use some sort of belt. You'll find all different types. It just depends on what the builder likes to use and kind of what they're interested in. So in this case, we have our motor right up here, and we have some bolts going into the back of our motor to hold it stationary. But again, we're using this dovetail trick here. This is to relieve stress specifically on this corner joint right here of the upright. If I, for example, didn't have this, all of the force of the hit on the opponent would go right into this joint connecting these two, or right here, and this would end up snapping. So I'm imparting a lot of the force into the frame or into the main body by doing this and making it so that this piece doesn't necessarily have to be as heavy or as rigid, because it ends up putting a lot of its force into the body. This is a very small gap for 3D printing, at least. So these pieces end up being press fit instead of a loose fit, and since they're press fit together, there is a lot of force transfer. There isn't really a dead zone where if one moves, the other doesn't. The other thing here is I have this motor block right here. Instead of opting for the regular motor mounting solution of just mounting it using these two bolts right here, I opted to have like a confinement block almost, where the motors are going to be held in place. The reason that I decided to do this is I just felt it was more secure than having the bolts out here. It also made for easier serviceability. So if I wanted to swap out my motors, I would just take this block off and pull the motor straight out the top instead of having to take screws off and take the side armor off. I can just pull it straight up and be able to take that motor out and replace it. And the same thing for being able to take out a wheel as well. It just improves serviceability and combines already used bolts. When holding on this top plate right here, I'm already having to put bolts in there anyways, so I might as well use it to contain the motors as well. Other than that, I don't think that there's anything like super unique or interesting I'm doing. I'm currently working on prototyping this robot, printing out different pieces, and being able to test all of the different tolerances and fits to make sure that everything works the way that it's supposed to. Hopefully pretty soon here I'll be able to get some videos of it working and start diagnosing any potential issues that I have and testing it out to see how good it is, testing it on some spare pieces, driving it around my apartment, being able to program it and have some fun. I hope you all enjoyed this both introduction to 3D printed BattleBots, but also an introduction to my BattleBot Byte. Thank you all for watching, and I hope that you have a great rest of your day.